All right, so yeah, so this presentation is it's not testable, a little more colorful, but I guess the ultimate concept behind this is really to develop a toolbox of innovative ways to go about drain maintenance. A lot of it applies to construction as well, but in an environmentally friendly manner, but also achieving the drainage requirements as well. So there are a number of tools and techniques in the box. I'm going to go through all of these in a little more detail with some images so you can get an idea of what we're talking about. So I won't belabor this slide. One thing I do want to point out, and Sid, you hit on this one perfectly earlier, in that with the Dart team especially, we realized at one point that we had an awful lot in common. And these next two slides really do show that. We look at the drainage benefits of some of these tools and techniques, and we look at the benefit to erosion, sediment, the movement of sediment, reduction of maintenance frequency or the amount of maintenance required. Sometimes even some of these drains can become self-maintaining, and ways of looking at grade control. So great benefits for drainage. Also, though, those exact same benefits apply from the environmental perspective. And certainly some way have more benefit environmentally or from the drainage side, but there's a lot of similarity, and that's the point that I want to get across with a lot of these tools and techniques. And a lot of it can be done with no extra cost. It's just a different way of going about things. The standard maintenance, and I've seen it change in 20 years, but the standard maintenance used to be top to bottom, get it cleaned out and be done. You can oftentimes get away with a lot less and at a lot less cost and a lot less managing as well. So this is a really broad sort of concept here about natural channel design. And so many things I'm going to talk about in this presentation actually fit into that. And this here is, as I noted on that one overhead photograph earlier of the regulated areas, the Steenstra drain. This was a big project in the early 2000s with a lot of partners and was trying to restore this. A lot of things needed to happen to this drain, but one was to put back a natural channel design into it. It was a cold water fishery with brook trout in it. And so started with a lot of different techniques employed in this one here, and you're going to see it a few times in this presentation. But this is after construction. It doesn't look like much, but this is as it's had a chance to develop over a few years. You can see how much it's turned into almost looks like a natural water course. This is in fact a municipal drain, even though it looks like a stream. So in a natural channel design, you can look at a lot of things. It can be structures, it can be channel form. The one design here is just trying to incorporate as many natural features as possible into the drain: riffles, pools, floodplain areas, things like that. So it's done really well. It's a great example of a project that has held up over. It's been almost it's been over 15 years that this drain's been in place, and it hasn't been maintained since, or has had no requirement for maintenance since that. Some of the features in that natural channel design are Newberry Weir. This is not the Steenstra drain. This is a different example, but an idea of Newberry Weir is really it's a rock riffle, or some might think of a set of rapids, but there's multi-purposes to a Newberry Weir. All Newberry Weirs are designed same, not dimensions, but same slopes, and for different purposes. This one here was actually built to try to redirect the flow of water. So it took the upstream water. When it hit the weir, it actually pointed the water into a narrow defined channel going downstream. And that's tried to reduce erosion on various banks, but also to get a good, healthy, narrow, deep, low flow channel. Another Newberry Weir, this is looking upstream, but this is just a classic design of what a Newberry Weir would look like. This one here, while it can serve as erosion protection. It can help direct flow downstream. This example here was to actually back up water to a perched culvert. And this had a lot of benefit from a fisheries perspective because there was an enclosure on this drain, which meant there was a loss of habitat. but because they were able to build a weir up and it's passable by fish, that fish were able to access the culvert now. So even though some of the drain was lost, it actually opened up more channel to fish passage. Sorry. So benefit there. And this would be now would be called an offsetting measure, but it just shows another purpose of a Newbury weir. This weir here actually was built to protect an eroding bank. And how it did this was by backing water up about 30 centimeters and changed the course of the flow. So the Thalweg, or the main current of water coming down the drain, actually shifted and changed. And that took the erosive forces off the bank itself. So multiple purposes for a Newbury weir. It can be used to step down channels, erosion control, back up water for an intended purpose. In this case here, there were no tile outlets, so we weren't backing water up into tiles, but it's a good tool. Another one is just a narrow channel. There's been a lot of focus, especially for water quality and a habitat perspective, keeping water flowing in as narrow and deep a channel as possible. And it shows what can be done. This is an example here where the first part of the screen, and I don't know if you can see the cursors or not, but you can see how much wider the wetted width is from here to the bottom. And short ways up, you can see it's much narrower. The first part was actually, by all intents and purposes, a very narrow channel. They cleaned out as little as they thought they could. But with a little tweaking, they found they were able to actually get an even narrower scoop going upstream. And that was important for this one here because this was a Class D drain. So it was cold water with brook trout in it. So I had to look at as many ways as possible of getting through the approval processes and the lowest amount of impact. So back to this whole low flow channel idea. It introduces as well the two-stage concept. This diagram is actually taken out of the DART protocol, but what it is, it's a two-stage channel. So you've got your low flow channel and you've got a bench on either side of that channel. This could be constructed in a new report or as drain maintenance. Very narrow drains with maybe a 1 meter bottom, very tough to do this. But if you have a drain that's 2, 3, or 4 meters wide at the bottom, much easier to do this. So the idea is that it has the capacity to convey the low flows, but it also has that bench or that false floodplain that can accommodate the higher flows. The sediment stuff that is transported in the channel during higher water events will actually settle out on the bench, the vegetated benches on the side. And this next picture I'm going to show you shows that very well. That's what it's doing. But because it can convey sediment and hold sediment, it requires less maintenance, reduces erosion, less turbidity, and less sediment export downstream into drains or natural water courses downstream. And here's an example here. This is just coming out of a flood stage where you can see the low flow channel again, but you can also see the amount of material and sediment that was deposited up on those benches. And those benches are vegetated, and the sediment may settle out there, but the vegetation will keep growing. So if you wanted to maintain this two-stage drain, you could just go and follow the actual low flow channel and just do the bottom scoop on that. But in this case here, it's actually maintaining itself quite well with a nice deep narrow channel. There may be spots where it changes, but then those are the spots you can look at doing a spot clean out on. So it can be a two-stage with the center low flow channel, or it can be two-stage with just a low flow channel and a bench on one side. This case here is actually this is a construction project, but shows that because on the one side there was no room to take that bench back as far as access and dealing with the row of spruce trees, the bench was created on this side here. And during a high water event, that can hold quite a bit of water before exceeding the top of bank. Just another example here of a bench on one side. Okay, so this one here is on the point bar. It's the same idea, except it's a much smaller scale, but it allows this, and during a high flow event, this will be a large pool, and you'll get a lot of material coming back in an eddy and depositing on that exposed bank there. The Steenstra drain again. This is there are two of these on the Steenstra drain. called an offline sediment trap, but they also serve as a wetland. And there are many types of sediment traps. So this one here is one I don't see very often because you need to have the real estate to put it in. But what's happening here is this creek is flowing, or the drain is flowing from back behind these trees down towards the bottom of the image. One of the problems with the Steenster drain was a really large bed load of sand. And that was ending up on manicured lawns downstream and also filling in a lot of the habitat features on the drain downstream. So in this project, what they did back here, they created an inlet that when flows were high enough in the Steenster drain itself, water was able to enter this wetland area, settle, and then filter out and make its way back into the Steenster drain. So the idea is that, and we haven't had any maintenance issues in this section at all, but we have had this area cleaned out twice where we've had sand removed. And it's very easy access coming off the county road. They can come in, fill a dump truck or two, and move that material out. That material is there rather than in the downstream portion. The classic online sediment trap is just that. It's in the middle of the channel. It's an area that's slightly deeper. And the idea is that it will collect and hold sediment, which you can see in this area here. During a maintenance project upstream, it's actually holding and collecting the sediment in these traps rather than moving down through the system. And it's doing a really good job of that right there. They can also be, from a fish habitat feature, good refugia pools. Another idea of a sediment trap here, and this is specifically to coming into a wetland, so it's avoiding wetland work, but it's also pike spawning. So this drain here was cleaned out to this point, but the bottom, it might be 200 meters, was left with the vegetation on the bottom. Okay, so the sediment, so that's actually collecting sediment as well before entering the main river downstream, but it's also holding back sediment in here, almost like a vegetated weir. So different types of sediment traps are not always online. You can have them offset, or you can have them downstream in the drain. Another thing we're seeing a little bit more of as we look at headwater storage and trying to slow the movement of water downstream is the creation of artificial wetlands in the drain. This one here is a tile drain coming out into an open drain, and recognizing with some of the activities that are happening on the drain that we need to slow the water down temporarily, and you do so through the construction of an artificial wetland. And this is one as well where a pipe comes in and then goes out through a small open channel. But it's holding water when it needs to hold water, and basically functions as a wetland. Okay, another concept that's actually in the DART protocol is stage cleanouts. And really, it can mean a number of things, but staging means it's conducted in different stages. So doing a section at a time. You can look at it geographically. You can also look at it over time. But in a maintenance project, really what you'd be doing is you alternate between reaches. So you'd clean out one reach of the drain, and you work on a different reach afterwards or before. The idea, it depends on the sensitivity, and staging can also occur over, it could be a drain that needs to be cleaned out, but it could be done over 2 or 3 years, section by section. One of the things we've had I've probably seen it twice now, but where you build these sediment traps or fish refugia pools prior to doing the staging. That way you can do these sections at a time. It actually gives the fish a place. You'll push fish up and downstream as you do your maintenance. It gives those fish a place to settle out, and you can skip over them when you're doing your continuing the maintenance. Another concept also in the DART protocol is just spot cleanouts. So rather than doing the full length of a drain from top to bottom, you can identify areas where there might be sediment bars, there might be an obstruction, might be an eroded bank, things like that have caused problems in the drain itself, can be approached on a spot by spot basis. And it can't always be the case, but it's definitely a tool that does work in many occasions. This one here is another way of looking at, there was a debris jam across here, but there's also an upwelling of gravel, of groundwater coming out of the gravel here. So important for brook trout spawning. So we're able to actually get the debris removed, get the obstruction out of there, yet maintain that low flow channel without actually impacting on what was happening in this area right here. Beaver dams, you'll get to enjoy beaver dams as drainage superintendents, no doubt. They can happen in individually, like some, or in this case here, this was there were 13 drains or 13 beaver dams on this drain, all within no more than 400 or 500 meters. One of the biggest things with beaver dams, though, is removing the beaver dams slowly. So it's taking a little bit out of the center here, letting the water come down, coming back, lowering it again. So it's something that's done over time. It's not something that's done real quick. The problem with removing a big beaver dam too quickly is that you have a rush of water moving downstream and and we've seen wash out road culverts or any crossing for that matter. So doing them in a safe manner. One of the things that we often promote in discussion with our drainage superintendents in our watershed is when you have a series of 3, 4, 5 dams, is do the usual lowering, but also keep the bottom 1 or 2 dams intact and leave those till the end, because those become really efficient sediment traps. And then as you remove that last dam, you can remove the sediment at the same time. It just avoids continually dumping sediment down as you work your way up through the beaver dams. And there's other ways of doing the maintenance itself. One is just a no touch on one side. And so it's similar to a bottom clean out, except you're not actually scooping the full width of the drain. You're keeping some of the features on the one side. And I do believe that is Sid Vanderveen holding the net. But I'm not too sure because I haven't seen Sid get too dirty too often. So I do believe, Sid, correct me if I'm wrong, but that is you, right?
I think it is, yes. And that was just outside of Ottawa somewhere. We were doing some electroshocking of streams that are drains to find fish.
And I heard you were a heck of a netter.
I'll go with that.
So yeah, thanks, Sid. One of the, I guess the key takeaway on this slide here is that when electroshocking up through this drain, the vast majority, if not all the fish in certain spots, are going to be on the vegetated side where there's cover. So you've left that habitat in place, but you've also gotten rid of the material that you need to get that water flowing. Then there's brushing of the bank slope. And a great example here is where you have a gravel substrate or a rocky substrate, and there's really no sediment to deal with per se, but you have a lot of vegetation that's actually blocking and slowing up the flow. So in this case here, instead of going and doing the standard full clean out and just dipping it, all that was required was a brushing of the bank slope. So it's just knowing when you can get away with less effort on these projects. Here's an example of a perched culvert, and one of the things we can do to address this is we can go back and again keep these in mind as offsetting measures as well from fish habitat perspective. Is that you can put Newberry weirs in or create weirs to actually backwater up to have these perched culverts flowing, if not all the time, more frequently, anyways. Then you can integrate different features as well. This here was on a drain that where it was eroding back quite severely, but there was a water line. So we had to armor this. But in doing so, we actually left some of the habitat features that were here. We put a Newberry weir right here, a very small one. Did the rock line on one side, and then left this side no touch on one side. So you can combine all of these features. And again, you can put natural channel design concepts into all these drains. Other things to think about and maintaining a lot of grass waterways exist in drainage reports. Also a tool that can be used in new drainage reports. But the idea is that where you have fairly significant relief, you can put grass waterways in to move the water safely through the fields and not erode that valuable topsoil. This is an extreme example. A lot of times we see maybe one through a farm, but they're just shows what the grass waterways look like, and you can move equipment right through them, and sometimes even crop those. Grass waterways are just trapezoidal channels. This is an exaggeration on the vertical scale, but they're going to be wide enough in the low draw to handle the amount of flow that's expected. They're a flat bottom, and water needs to get into them. That's one of the biggest things about maintaining grass waterways, is ensuring that water can still flow overland from the field and get into the waterway. A lot of times what happens, they don't get maintained, and you get sediment built up on the sides, and the water hits that edge and just runs along the edge of the field and causes problems elsewhere. So it's important from a maintenance perspective that grass waterways get maintained as well. Here's a well-functioning grass waterway. You can see that the water's, in this case here, not losing a lot of topsoil, and that's the goal with this one. And it's functioning well. You don't see water ponding on the edge of the field. Water is able to get in and filter into the waterway and move down safely through the field that way. So, and in contrast, here on the left side, we have a pasture or a meadow that's is vegetated, slows the rate at which water moves, also reduces the amount of erosion that's happening. Whereas on the right side, you have a fairly significant draw through a field. It's not protected, and what you're seeing is brown water, and that brown water is really your topsoil that's being lost. Another feature that can go hand in hand with a grass waterway is a water and sediment control basin, known as a wasp cob. And they can be in line on the grass waterway, or they can just be in a field without grass waterways. It's a good measure to control the rate at which water flows, which also means or reduces the amount of erosion. So they're just a berm that's constructed that holds water back temporarily after a larger rainfall event, with a hick and bottom, sometimes with a catch basin for the extremely high flows or a spillway over top. And it just slows the rate at which water moves down through the next portion of the field, and ultimately holds back significant amount of sediment or topsoil and avoids it from getting into the water courses downstream, which could be an open channel drain, which also means more maintenance the more sediment that you have. So here's an example here where we got a nice berm down the center of the field, and you got you can barely see it right there in the middle. There's a little orange top of a hick and bottom, but you can see it's holding the water back and releasing it in the tile system below. Some water is seeping through a spillway or in some manner through here, but you can see the amount of water downstream of it, or down gradient of it, is extremely minimal. So you're not seeing much erosion happen in this field because of what's going on up here. And this last one's a little bit of a case study. I got a few slides on buffer strips, but when we think of buffer strips, we think of a grass or vegetated buffer strip along the side of the drain. It might be 1 meter, 2 meters, or 3 meters wide. And we think of the purpose being to prevent erosion, prevent equipment from coming into it, capturing nutrients, things like that, the standard buffer strip arguments. But this is an example of where we had extremely light soils, so really good quality soils for growing market garden vegetables, things like that. And we had a windstorm. The soil was dry. If anyone remembers 2012, it was a very warm spring, but the soils were dry and we had a big storm come through. So much so, in fact, that they had coming through the field, they had a plows on the road removing drifts of sand and soils. So you can see the amount of, I guess, wind drift here in the background of the one top left. It looks kind of like a snow squall, but that's all dust and sand that's moving across these areas. The top left photo, what you're seeing is the drain actually being filled in. That drain filled in within a day. And the reason it did so is because there was no buffer along the edge of the field. It was used as a access route corridor. And you can see in the bottom right, active erosion. And a lot of it's just sediment, or sorry, soil that's moving across the field and dumping into the drain. So the bank itself isn't actually eroding away. It's just, it's taking in all that material. Another picture here looks like it's getting dark, but that's just the amount of dust in the sky, but the drain is filling in, continues to fill in. You see the next day that there's not much water left in that drain at all. And that's from 24 hours. So you see what's happening where we don't have good quality buffer strips. That's the vantage point I'm taking this picture from here is looking north. The next picture is going to be looking south. And you're going to see a significant difference in the effect of that buffer strip. That drain is still has capacity, still functioning, and we're not seeing erosion over the banks. So just another perspective, another way to look at buffer strips. It's not always about the water moving over or through it, the quality of the water. There's also there's other factors to consider as well. So those are the tools in the toolbox. And I guess, why do we want a friendlier approach? I'm a fisherman. I love fish. I look at these and I think this is enough motivation for me. Maybe not for everybody, but it's to understand that these species of fish, these quality of fish, live in municipal drains. It's going to be fascinating. So think outside the box and kind of keep as many of these tools in your toolbox as you can. That's all I have. So thanks everybody for sticking through this. I know I've been talking for a long time, so I hope it came across all right.
No, that was great, Davin. I love those buffer slides because again, you look at it from one perspective, Davin, and I know you've got the broader perspective, but from a stream, from a fish, from an ecology, you don't want that sediment in there. From a drainage superintendent's point of view, the last thing you want is this drain to fill in. And from a farmer's perspective, the last thing you should want is the layer of soil that's going to grow and make you money ending up in the stream. So if we put a little thought to it and change the way you do things, everyone can actually benefit from it in the long run. So those are great slides, and I remember you showing them to me in 2012. It was shortly after you were emailing me those photos, and I thought, yep, that's a different way of showing things. But yeah, that was old Lake Smith, right? That
is, yeah. Lake Smith, Lake Burwell, Lake George, those three lakes in the Thetford-Klondike Marsh area. Yeah.
Yeah.
So that's a real muck soil, if you can actually call muck a soil. It's real organic, light stuff. It flies around, and so yeah, very valuable, but not when it's flowing downstream.
Yeah, exactly. And I mean, literally, snowplows out pushing that away. It was crazy.
Any questions for Davin? None whatsoever. Did you all get his 2 presentations? Okay. Just an FYI, the one that he just did there's nothing on the exam on that, but his first one there are 3 or 4. You're down to about 3 or 4 questions now in the Conservation Authorities Act in the quiz in the exam, but yeah, so there's a few on that, so keep that handy. All right, Davin, again, thank you very much. Every year I go, yep, this is good. This is the way I like drains and CAs working together, and I should tell you, Davin is a boots on the ground. He made fun of me for not getting out very much, and that's true. I didn't get out nearly as much as I would have liked to have, but Davin is very much a boots on the ground kind of guy, and I think you try to attend a lot of the on-site meetings, don't you?
Yep.
And he also ends up going to the LICO DSAO convention and spends a little time with superintendents there as well. So get to know your local CA person and keep them engaged as well. Keep that good relationship.
Yeah, that's right. Can I add one thing, Sid?
Yeah, absolutely.
And I've mentioned this to other staff and colleagues that I've seen a major, almost like a tidal shift in the uptake and these features. And I guess everything changes over time, but I think it's changing in the right direction. I'm seeing a lot more projects, and I tell you this, a lot of the people that I'm working with now have come out of this drainage superintendent's course, and a lot have actually sat through my presentation. So it's developed really good relationships and some really good some projects out there.
Awesome. Yeah, that is good. All right, one last chance. Any questions for Davin? Okay. Thank you again, Davin. Very much appreciate it.